Hello, and welcome to the series where I create my very first game in Unity by myself. So, in this series, I'm going to create a game based on Conway's Game of Life and Cell Machine created by Sam Hogan. Now, the reason I want to create a game like this is because it implements logic, because you'll have levels, enemies to beat, and you'll also have a lot of freedom in the end, because how it's going to work is that there's going to be a certain set number of levels. That's kind of like Cell Machine, but once you beat all of those levels, you'll enter free mode essentially, which lets you play like it was Conway's Game of Life. And so here's how I plan on making it to work, because cell movement is a giant struggle here. So I'm in Unity, and this is a diagram. So I have it simply here that this white barrier is going to become a parent component that holds a bunch of nodes. Now, what's a node? A node is simply a box. And a node in the game will actually just become a position. So it'll just be a list of positions. And you'll have your main player. In this scenario, it'll become the red cell. So say this red cell had to move right. Then it would grab the next node in its set path. So if it was up, then it'd go up, down, it'd go down, left, it'd go left. So it had to go right. So it had to go over one. So it'd grab the next node's position, and then it'd move over. So for you to understand that black is basically empty squares in this scenario, I could have it set to nothing. But yeah, that's how it would work. And then there could be multiple cells that could have multiple nodes. So that's essentially how I plan on making it work, but I'm not going to do it straight into Unity. I'm actually going to try and make it in Python separately and see if that works. This script to sort of work. It's not customizable, but once the initial configuration has been set, it happens. It plays out. So here's how it works. I first create a game board, 5 by 5. I can change this to say 7 by 7. And this is not. Just give me a quick second. Yeah, well, I'll do that later. Or actually, no. Size equals 5. So I'm going to create a game board of the size. So I'm making this a lot more dynamic now. So I can change it if I'd like to, which is pretty smart because I'm not, I don't want this just to be for 5 by 5. So how it works, back to that. So you can clearly tell this isn't scripted. So how it works, I create a game board of whatever size I specify. Now I should be able to give this to 6 to 6 or whatever that is. And then I give the player a random increment or position on the board. I only give it, I don't assign it yet. So that's the player's position. I give it a rotation so that it knows which way it's going. And this is just a function to print the array very nice and pretty like here. Otherwise it was printing like trash before. I think I just crashed it. Nope, I didn't. Alright, it's working. So yeah, 5 by 5. Now how it works here is then I print the initial position of the player just so that you know what it's looking like. The player and the position, so I know what it's looking like, right? So you know what it's rotating. I set the player's position finally on the game board, and then I print the initial game board, and then I print a blank line. And then here's where the magic stuff is happening. I'm just going to see here if it's going right or left, and that moving on the, if it's going right or left, then it'll move on the y-axis, up and down, moving on the x-axis. Alright, then I'm just, inside of here, it's just moving it accordingly, right, left, up, down, setting the position and resetting the board, and then I'm just going to do move player. I could make this more dynamic where it handles input from the command line, but I'm not willing to do that right now. So here is what we have. So this was the first setup. So it was set to 4, 0. And if you guys don't know this, in computer programming, numbers start at 0. So when you define an array, 4, it means start at 0. So 0, 1, 2, 3, 4. And that's x. No, wait, that's y. 0, 1, 2, 3, 4.